Hello, everyone. I'm Nicolas from SUSE. Here is Tom Chin from Edgenesis.
Hello.
And today we're going to present you how to build an end-to-end IoT gateway with Shifu and SUSE Edge using Kubernetes.
So, hi everyone. I'm Tom. I am the co-founder of Edgenesis and also the TSC co-chair of LFH's Infinity Edge AI project.
And I'm Nicolas Beloin, Edge engineer at SUSE, working on the overall Edge solution there. So today's agenda is pretty simple. We're going to introduce you to what is an IoT gateway, what is SUSE Edge, and then do a quick demo and walkthrough to how to set up that whole gateway using SUSE Edge and Shifu. So I'm going to let you there.
So first, I'll be introducing the Kubernetes native IoT gateway. What is a Kubernetes native IoT gateway, and why do we need it? So, to answer that question, we need to talk about the current status quo of most IoT system in industries, which is usually the one on the left. We often had a bulk of heterogeneous devices. Each device comes with their own protocol and some vendor-specific systems, making hardwares and software deeply coupled. So developers need to solve that. In order to solve it, I think we should just learn from operating systems. For example, Windows or Linux. When we plug in a device, a camera or mouse or keyboard into an operating system, it automatically detects the hardware, loads the appropriate driver, and connects to it. It is completely hidden for the user and application developers. So if I were to develop an Android application, I won't be worried about how to control this specific model of, let's say, vibration motor or speaker. Android provides a unified SDK for me to access. So at Agenesis, we're doing the same thing with our Kubernetes native IoT gateway, Shifu. Next slide. So the way we do this is that Shifu abstracts IoT devices into Kubernetes pods. And within the pod, there is the driver of the device. So a driver means that it doesn't only do the protocol translation, it also does um, transformations, data processing, things like that. So, and on top of it, it's a layer 7 proxy. So after those two combination, raw data goes in from the device and application ready data comes out. And we encapsulate all the device specific logics inside the driver. So by doing so, application developers will only focus on business logic, doing what's important for the company. Next. So, in a factory or industrial use cases, we often have devices with different protocols scattered around different places. But with the power of Kubernetes, SUSE, and Shifu, we can connect them to the nearest cluster. We can manage IoT devices in a centralized location, just like we manage softwares. Application development with Shifu will be as simple as building a web application. Next. At Genesis, we are dedicated to solve the IoT interoperability problem to seamlessly bridge AI and the physical world. So to date, we have connected more than 2 million IoT devices. We have deployed over 300,000 instances across more than 10 industries, and we're trusted by industry leaders and Fortune 500 companies. We're also actively participating in open source associations like the Linux Foundation, CNCF. Next. So some of the use cases for Shifu includes in-vehicle AI agent that you can chat and control window media player, uh, smart inspection to increase operational safety in a mission-critical power plant, teleoperation and fleet tracking for a large energy corporation to cut down operational costs, lab automation that reduces the time for developing an IoT platform from years to just weeks, smart camera integration that connects to more than 1 billion cameras securely at the edge, a smart agricultural co-pilot that can scout to thousands of tractors for strawberry growers. That's just some of them. Yeah.
And now I'm going to present you what is SUSE Edge and how SUSE Edge can help you build this kind of applications on the edge. SUSE Edge is, I would say, a whole solution. It's using different components for uh, all together or only part of them. Um, it's based on SUSE Linux Micro as its base OS, and then you add the Kubernetes, be it K3s or K2, and then you add over it all the uh, ecosystem and tools for the management, be it Rancher Prime, be it virtualization, or you can use things like Elemental, Metal Cube, or Edge Image Builder to deploy other clusters and have your all uh, edge clusters for all the locations, all managed through a central cluster and deployed using the same tools and using the same base image for all your locations. So that's exactly what we have for here displayed. We have a management stack with uh, using either bare metal or private or public cloud, whatever. Uh, you have your SUSE Rancher Prime on this. You have Fleet for GitHubs. You have, say, Elemental or Metal Cube for deploying the downstream clusters, and with that you have the everything you need to manage all your locations and all your clusters from this environment. And then on the other side, you have this runtime stack that is the downstream clusters, where they can run on your they run on the edge, be it like bare metal, small gateways, or sometimes bigger factory-wide small uh, small server rooms where you have your local private cloud, and you have running on top of that you have SUSE Linux Micro that will be the base layer operating system, and then you have your Kubernetes, and then you can have, if needed, storage or security at the edge, and then above this, your container of virtual machine workload that will do everything needed uh, directly at the edge, controlled from the management stack. And this is basically what we are going to demo and walk through now. It's building the IoT gateway image using Edge Image Builder, and this image will be then used to bootstrap the gateway. That is a simple SBC device, and then using a USB drive for this, and this will be then bootstrapped using Fleet for getting all the configuration to the cluster. We then, with all that configuration in in the cluster, it will discover and connect to the IoT device using Shifu, and we have a web application to control all of that. So this is how the demo will work. Now let's get into more details of this. So first step, we are going to build a gateway image. And for this, we are using the Fun Home scenario of Edge Image Builder, and that is using Elemental for registration. So the configuration is pretty simple here because it's kind of the lightweight scenario. So we just have to specify like our things, natural things like architecture, where to install, registration codes, obviously, what users to create to on the gateway, additional packages to install, and then we have this elemental config that is given by the management rancher instance, and that will give all the information for the downstream cluster when it boots up to contact the rancher cluster and then deploy everything that is configured to be deployed. So this makes a few images, a few files that result then in the image when we run the podman or docker command to build the all images, the all image using Edge Image Builder. And then when it boots up, it contacts the rancher cluster and fleet uh, take the control and deploy all the resources needed to do everything regarding with discovering the devices and using them. So
All right. So after the cluster has been bootstrapped, um, several containers or several pods will be deployed into the IoT gateway. And then Shifu discoverers will be start looking for devices based on either IP address or multicast groups or some protocol specific signatures. And once the device has been discovered, the device discoverers will notify Kubernetes or K3s, and then Shifu controller continuously look for events. And then when that happens, Shifu controller will spawn the digital twin of the device, which we also call the device Shifu, in a form of Kubernetes CRDs and deployments. Yeah.
so here's the overall architecture. We will have two locations that one of them has been deployed using the image I just built. The other one got imported so that it's another way you can add clusters to Rancher as well to manage them. You don't have to use all the tools that we provide. And on this, you have this. On each location, you have an ingress controller that will serve the web app and all the device Shifu endpoints, and we have the several devices, and we have obviously the rancher agent, the fleet agent, and Shifu, the device discoverer, and so on. So those will do all the heavy lifting for getting things working. And I'm going to start by presenting you how it looks like in the Rancher Manager that shows the different clusters. So here we have the two. We have the local cluster that is the management cluster, and we have the two gateways that are registered into the system. So here we have one that says is using Elemental and AirKey2, another one that is manually imported and using K3s. Uh, and we can see when we go here into this continuous delivery tab that we have set up a Git repo that will basically have all the information of what to deploy into each of this cluster. and we'll have all the and we'll take care, and Fleet will take care to deploy that on the clusters. So I quickly go on what is in that Fleet repository. So here we have a deployment of Acri that will discover the devices. We have an additional discovery handler for Acri as well. We have the Shifu Acri adapter. We have Shifu itself, and we have some configuration for all of that. So the web app, we have the ingress configuration, we have we have all the config maps for Shifu. So I'm going to go on this one for the LED device and let Tom explain to you what's going on this.
So, thanks, Nicholas. So, in order to connect to a device, we need to configure the protocol of the device and the APIs of the device. So, inside the config map, we actually specifies what instructions or what APIs a device has. So, for this particular device, it is a LED for based on OPC UA protocols. Any OPC UA protocols APIs can be mapped to OPC UA node ID. So as we can see here, we have a number, we have light, we have get status, get server, etc. So which means when I deploy this device Shifu or digital twin, this config map gets loaded into the device Shifu, and Shifu automatically creates those API endpoints. And when I crawl or send an HTTP GET request or put request for write, for example, for number, it will translates to OPCUA node ID namespace 1 and s equals number. So that part is the protocol translation. And then if we're using a driver type of devices, then the instruction will be much simpler. So there are two types of deployments in Shifu. One is with proprietary protocols, the proprietary drivers. The other one is with public protocols like OPC UA or HTTP, MQTT, uh, things like that. Yeah, back to you, Nicholas.
Okay, so now that we have everything deployed and configured, the we get all here in the Rancher UI. We can see all the workloads that got deployed. So here we see exactly what we have in Fleet. We have the daemon set for, well, we have all the Acri S7 additional discovery handler. We have all the Acri Elm chart that got deployed. We have the Shifu here, Shifu itself, the web app, and here are the devices that got discovered by Acri and that got integrated into Shifu. So here we have the device Shifu deployments related to them, and all of this is done is manageable from here. Is also manageable from, like, you can interact with the device using this web app here. So I'm going to go on to this one if it wants to work, obviously. Here.
So yeah, this one is deployed on my side. So we have three devices. One is the IP camera you're viewing at the moment, and we also have a PLC on the right side, and then we have an LED on the left side. The PLC is running the Siemens Edge 7 protocol, and the LED is running OPC-UA, and the camera itself is running RTSP, and we can control them by just UIs.
Yeah. So here, for example, I just turn on one of the LEDs on the PLC, and here I can say 235 and set the value or get the value as well. So there's a bit of latency, but it's mostly due to the camera. So, and on my side, I have exactly the same kind of setup, except not with the same hardware. But it's also controlled via OPC UA and the Siemens S7 protocol. So it's exactly the same here. So if I get the value, if I set a value here, so say 5, for example, I can also set the value, and it should update if the stream didn't stop here. Yeah, it's changed the value with latency as well. Even though it's local, it's just encoding time and things like that around the camera. And for same goes for the LEDs, just under that are controlled using the S7 protocol in the end. But for the web app, it's just doing a post on the endpoints. And on the deployment side of it, it's just those three deviceShifus and the ingress that are doing the work. Here we are doing it locally, but you can easily imagine having an application running in your management cluster that connects to all of these endpoints in all of these locations. Maybe even a controller, a custom built controller running on the management cluster that automatically discovers all of those locations and add them to a central control panel where you can control all your locations from one point. So, um, here are where you can find the information about what we did here. So, on the SUSE Edge documentation, you have the Elemental quick start that basically goes through all the steps to build to configure the management cluster for Elemental and to build an image using EIB for this kind of cluster. And then how to set up fleets as well. And on the Shifu side, here's the GitHub repository for Shifu and the GitHub repository for the Acri adapter that we used here with all the configuration we used here as well. Did I miss something on there?
Yeah,
Or?
pretty good.
Okay. Then thank you all for watching.